All right, so today we're going to begin this last section, statistical experiments, where you are going to be designing and running a statistical experiment. I know that some of you had statistics in year 12, right? And you did something very similar, but you were given the data. This time what we're going to do is we're going to be looking at an experiment where you're going to determine the experiment and build your own data set. Okay? So before we do that, we get into those sections and then we talk about the measurements. We're going to do a little matching exercise where I'm going to give you a list of words and a list of definitions, and you're going to match the correct word to its definition. Now, some of these, again, if you've had some statistics in the past, you'll see they're very easy. Other ones you might have to think about in a little bit and work on. What I do not want you to do is look these up. So laptops down, please. Phones put away, because I want you to really think about the words and think if you can think about putting the right word with its definition. Okay? If you are completely stuck on something, then ask your neighbor. It's fine, right? But try to do as many of them on your own as you can. So we're going to allow about half an hour for this. If you get finished earlier, then just sit quietly. And if you don't get quite finished, then we'll work on the rest of them together, because we're going to go over the answers together. All right? So I'm going to pass those out, and then as soon as you get them, just begin matching those words. All right? So you have your list of definitions, you have your list of words, right? Now, did anybody get all of them or put something for every single space? Yeah? Well, somebody? Okay. So it wasn't really expected that you would know every one of those definitions, right? But some of them should have been familiar, and some of them are just plain English words, right? So you could kind of figure it out. So keep that in mind as we're going through. When you're learning the vocabulary of mathematics, that these are just words taken from the English language. So they're not meant to be obscure or try to trip you up. So think about what you know about the words and try to apply it to the definitions that are specific to statistics in this case. Right? So let's look at the page, if I can remember how to do it. Okay. Oops, that's the assessment standard. That's not what we want. Sorry, it's a little slow. Okay, so here we go. So for observational study, 2 groups that are observed but have no treatment, right? Why do you think that's true? They have no treatment. All you're doing is observing them, right? So that's what observational means. So we're just going to see what happens, what they do naturally, right? Okay. Control group. Control group is the group that has no change. Makes sense, doesn't it? Right? If you control something, then you keep it from moving or keep it from changing. Then you have an experimental study where 2 groups are compared and one group has a change into the environment but not the other. Right? So we're going to perform an experiment. That means you're going to actually do something. But you're going to have 2 groups, but in order to see make sure that what we're doing is valid and is really having a result, we keep one group static. And then, in other words, they don't have a change, and then the other one does. Okay? Treatment group, that's the group to which a change has been made. A change is a treatment, right? So if it's the treatment group, then that's the group that you have made the change with. Treatment group, the group to which change has been made, right? Okay. Randomized experiments. Now, this one's one you might not know, but you're going to, because we're going to be working closely with doing this, well, pretty much right away. 2 groups are allocated randomly. So, in other words, I might pick someone from this table And I just as easily might pick someone from this table, right? You never know who's going to be chosen out of the population, out of the group that you're working with, right? And to be truly random, you're going to never know. But everybody has to have the exact same opportunity to be chosen. Explanatory or independent variable is the variable that is changing in the experiment, right? So I'm going to give you the medicine, or I'm not going to give you the medicine. So if I give you the medicine, to see the change, that's the change that you're going to have. Response or dependent variable is the variable, is the variable that is being measured. Okay? So we want a response or dependent. The change is dependent on what happened, right? So the variable that's dependent, let's see. Okay. Bear with me here. Causation. When you have evidence that A causes B. Right? That was pretty self-explanatory there, right? Okay. Single blind. Only the researcher knows who's in the control group and the treatment group. So I know that I gave them a placebo, and I know I gave them the real medicine, right? But they don't know. So that's single blind. Double blind, I gave them each something, but I don't know which one's got the placebo or which one's got the real medicine. So neither the researcher or the subjects know.
Why would you do that?
Because sometimes the researchers can have bias, right? So if I'm going to perform an experiment on somebody and I want to show a certain thing is going to happen, well, then I might make sure that the people who are already like that get the treatment, right? Or I might choose a sample of people that do what I want them to do, right? But if I don't know who's getting what, then you can't give that kind of bias. You can't do that to them. Okay? Placebo, a treatment that looks like the real treatment but actually has no effect.
What's the looking variable?
Oh, sorry, did I miss one? Okay. So we did bias. Oh, I missed a lot, didn't I?
No, it's just one above placebo.
Because I didn't do hypothesis either. Or is that further down?
Yeah, there.
Confounding, lurking variable, a variable that the researcher has not considered. So it's confounding or lurking. Something's lurking, you don't see it, right? So you might have something happen that you didn't expect to happen. Right? You weren't trying to measure it, but it still affects your outcome. Placebo, treatment that looks like the treatment. Randomization test is the process of testing if chance alone is influencing the results of the experiment. Something that we're going to focus on quite a lot in this particular set. Okay? So we need to test to see if chance alone is influencing the results of the experiment. So we might perform an experiment and it might look like we're getting these good results. But it's just a matter of chance, right? It wouldn't matter who I chose or how I performed the experiment. The same thing's going to happen no matter what. Okay? So we'll talk about that as we go. This thing is driving me crazy. I don't like controlling it from this. All right. And we get emails. Bias, something that causes the results not to be accurate. You've heard of bias before. If you have bias, that means you're kind of prejudiced one way or another. Okay? So bias means something that causes the results not to be accurate. The hypothesis is the prediction of the result. Hopefully everyone has at least heard that one before, right? Hypothesis, an educated guess. So you're guessing what's going to happen. So I think this, right? And then you go to prove it. Context, real-world facts behind an experiment. You need context to be able to make it clear what it is that you're trying to do and what it is you're trying to see and measure. Right? Treatment, a change which should result in the change in the response variable. Treatment group, the group who receives the treatment. That one's pretty good, easily self-explanatory. Sources of variation, factors that could adversely affect the outcome of an experiment. So I'm going to give you all something to do, and you don't do it. Could that adversely affect the outcome of the experiment? Of course, right? So there are things that can happen. You're not always going to get a good experiment. Okay, is that all of them? Did I miss some of them in this bouncy scrolling on this thing? Okay. How'd you do? Did you do pretty good? Or right?
Is treatment good group? Treatment group, is that the group to which the change has been made?
The group who receives the treatment. Mm-hmm.
Treatment group is down twice, and there's two.
It's down twice, and they give you two different definitions for it?
Yeah.
Okay, yeah, either one of those definitions would work, so that's why it's down twice. Yeah, it shouldn't really be twice, but I'm saying the same thing in two different ways, yeah. Okay? All right. So, if you don't know all of that vocabulary, don't panic, because we're going to learn the vocabulary. As we go through, we're going to design and implement an experiment, and then you're going to gather the data, you're going to graph the data. How many of you have used NZ Grapher before?
We had to last year.
Most of you, yeah. So some of you weren't in a stats class, you might not have. But good, because I haven't, so you get to teach me how to do it. All right? So we'll be using that to be able to bring out our data and print off some graphs and look at some different types of plots that we're going to make. Okay? And we're going to be, so we'll be designing our own experiment, a randomized trial. Okay?
Mm-hmm.
Any questions about any of these? Any clarifications or questions that you have about the vocabulary? Now remember, it's important that you understand the vocabulary because it's going to come back to haunt you if you don't, right? So if I tell you, I want you to find the treatment, then you better have to know what that means in order to do it. So don't toss these. These are very important to be able to keep you on track as we go. Okay. So the next thing we want to do